So today's topic is the states of matter, which is included in the chapter Matter in Our Surroundings in the chemistry subject. So the first question that you get into your mind is, what is the state of a matter? We could simply say it as, first of all, see around you. What do you observe? If I see around me, I observe a cupboard, a bed, a table, a chair, and etc. There are more things. Yes, all these objects are made up of matter, which has mass and occupies even the space. So there are three states of matter. That's solid, liquid, and gas. There is even an exceptional case that is plasma, but we don't want to discuss it now. We'll discuss it later. Let's dive into one topic. That's solid first. What is a solid state? A solid is where the intermolecular spaces are tightly packed in, or we could simply say as a solid is a substance where particles or the molecules are tightly packed. Then let's go into the liquid state. Liquid state, the intermolecular spaces in the liquid are partially packed where they move freely, and if we want to define it very brief or very deeper, we could say it as intermolecular spaces in the liquid are partially moving in. Then let's go to the gaseous state. In the gaseous state, intermolecular spaces are freely zooming everywhere. Next, if we want to define the gaseous state very brief or deeper, we could simply say it as gaseous state where the particles or the molecules are uh, zooming everywhere or loosely, freely packed. Next, after this, we will dive on to the one question. Will matter change its state? Yes, matter can change its state. That's solid to liquid. But I have a doubt. Do you heard these sentences? As your mom says, go boil the water, freeze the water in the refrigerator. Yes, all the works now what you're going to do, it comes under change of state and matter. Solid to liquid. Take an example. Here the solid is ice, liquid is water. Now you're converting the ice into the water. What will you do? Yes, you will actually melt it. So one process is melting. Next, let's move on. Liquid to gas. What would you actually do? Yes, you will keep boiling the water until it reaches its melting point. That's 100 degrees Celsius. And in that temperature, the water gets slowly converted into the water vapor. So in that process is known as evaporation. Next, let's come reverse order. Gas to liquid. That's condensation. Actually, we can see it in the water cycle. Next, liquid to solid. That's freezing. Next, there is even an exceptional case where liquid is not at all involved. That is solid into the directly to gas. That is sublimation. Yes, we have completed this topic, and let's move on to the properties of it. Properties of change of state in matter, or properties of states of matter. So the properties are the shape, volume, and the compressibility. For the solid, the shape is fixed. Yes, for the cupboard, the shape is fixed. The chair shape is fixed, the bucket or the bed, the shape is fixed. And the volume, as usual, if the shape is fixed, the volume is also fixed. The compressibility of it is very low because it has a tightly packed ions or the particles in it, and it has a fixed shape also. Even though if we try to compress it, it can't, because solids are made up of tightly packed. Next, we move upon to the liquids. We move upon to the liquids. So the shape of the liquids are non-fixed, because now take the example. You have a bottle here which is very fat, and you have a tiny glass here. Same amount of water, fill the water in this small glass and transfer the same amount of water into the bottle. And now, if you observe, the shape of water might be changed, but not of the containers. Yes, the shape is not fixed. I've said you already that if the shape is fixed, the volume is fixed. If the shape is not fixed, the volume is not fixed. The compressibility is low because if we try to compress liquid, just we might compress it very low but not fully. Let's move on to the gases. And in the gases, the shape is actually, it's non-fixed. It's non-fixed, and the volume is itself non-fixed, and the compress is very high as it's nothing visible to our eyes, and it's with freely zooming ions or particles everywhere, so we can compress it. Thank you.